We can describe how light will reflect off of mirrors and reflective surfaces using ray diagrams. However, there are a couple conventions we need to define. First, any light that bounces off of a flat mirror comes out with the same angle that it came in. So here, if I come in parallel, I have to come back out parallel. If I come in with some angle to the perpendicular, I come out the same one. Second, we draw all of our objects as arrows, and we draw all of our images as arrows. This just makes it easier so that we draw all of our light rays from the top of that arrow. Third, when we actually draw these rays, the real path of the light, where we can actually have light, is drawn in solid lines. Sometimes those light rays will not converge, and we'll need to trace back where they could have come from using virtual dashed rays. In this case, the flat mirror creates a virtual image behind the mirror, but we know in real life there's no light behind the mirror because it couldn't have gotten through. Now, not all mirrors are flat, as you know, and we typically care about two general types, concave and convex. For using these, we're always going to include three principal rays to analyze where an image is created. For a concave mirror, the parallel ray travels parallel to the optical axis and then goes through the focal length. The focal ray goes first through the focal length and then goes out parallel. The last one is the perpendicular ray, which will go at such an angle that it comes into the mirror and comes right back along its path. In order to do this, it has to go through C, the circle of curvature, or the center of curvature, which is just twice the length of the focal length. If you trace all of these lines, you should find where the image actually converges. If they don't converge, you may need to use virtual dashed lines on the other side to figure out where the virtual image would be. Now in the other case, we have a convex mirror. For a convex mirror, we have the same principal rays following the same rules. The parallel ray comes in parallel and then reflects as if it were going through the focus on the other side, so it will diverge away. For the perpendicular ray, it goes through C, just like we saw up here, but it's not actually going to get to C because it's going to reflect back along its path. The focal ray will try to go through the focus on the other side of the convex mirror, and it'll end up coming out parallel on the same side. Here again, we don't see real light rays converging, so we trace back where they came from and see that, hey, we get a virtual image on this side of the screen.